How to sketch a polynomial function. First, let's compare two graphs where a is the leading coefficient in both. When a is greater than 0 or positive, the graph of example 1 and 2 both end going up as displayed in yellow. However, if the leading coefficient a is less than 0 or negative, the graph of example 1 and 2 both end going down as shown in pink. This is called the function's end behavior. Therefore, if the leading coefficient of the polynomial function is positive, then it is an increasing function and ends going up. And if the leading coefficient of the polynomial function is negative, then it is a decreasing function and ends going down. Now let's look at the degree of functions. We have even degree functions and odd degree functions. We can notice that the graphs of functions with an even degree start and end in the same direction, as shown in yellow. And those with an odd degree start and end in opposite directions, as circled. Thus, we can conclude that when a polynomial function has an even degree, its graph starts and ends in the same direction. And if it has an odd degree, its graph starts and ends in opposite directions. The first step in graphing polynomial functions is to determine its end behavior and then determine where the function starts by examining its degree. The second step is to determine the type of roots that are present. To do step 2, the function must be fully factored first. This function has linear roots only. At linear roots, the function simply passes through the x-axis. As you can see, the function passes through all the roots. When a function has a double root, the function does not pass through the x-axis. Instead, it bounces off at the root. This is the double root, and as you can see, the function bounces off of it. Lastly, when a function has a triple root, a point of refraction occurs. This is the triple root and the point of refraction. That concludes how to sketch a polynomial function. Let's try an example. This is the practice problem. First, we have to look at the leading coefficient, which is 2, and it's positive, so this function must have an end behavior of going up. Then we look at the degree of the function. This function has a linear root, a double root, and a triple root, which adds up to a degree of 6, which is an even degree. This means that the graph must start and end in the same direction, so it starts going up as well. Then we find the y-intercept. To find the y-intercept, we plug in 0 for x because we are finding the y value for when x is 0. Which leads us to a y-intercept of -8. Now we can sketch the graph of the function. This function has roots at -1, 1, and 2, and a y-intercept at -8. So the graph starts going up, and the root at -1 is a linear root, so the function passes through the root. And at the root of 1, it's a triple root, so a point of refraction occurs. And at the root of 2, it is a double root, so the function bounces off the root. Here you have it, that is the graph of the function.